All right. Welcome to Module D. We made it. It's final module. A lot of chapters in the module. We have 4 chapters. So, fortunately, will not extremely deep, but I will provide a sufficient amount of questions that will delve into the more necessary concepts to go over. It's our most recent module to go over. So hopefully you've really gotten into the concepts that we've gotten so far, and then they're more fresh in they're fresher in your head. So yeah, so like again, we're not going to go over that many questions just because there's so many chapters and I want to get this out as soon as possible for you guys. It's pretty late as it is. Um, so let's get right into it. Chapter 9, we're going to start with number 3. And chapter 9 is basically about standardized units. So, and there's, besides like specific ways to measure something like milligrams and milliequivalents and such, there are other ways to, that can standardize a form of measurement, like units, for example. And we're going to be going into this. A lot of the math behind it is pretty similar to what we've seen in the past, but it's just to like really put out there that these units are there in pharmacy, and then there might be small conversions in between these units. So we'll just get into that. Number 3, Humalog, form of insulin. Humalog contains 100 units of insulin lispro per milliliter. How many days will a 3 milliliter Humalog pen last a patient whose dose is 35 units BID? So we've seen a lot of questions like this, right? We're given a conversion factor. We're given a certain amount that is available to the patient, and we're given a frequency. We're trying to find out the amount of days by that frequency will this amount last. So let's, our plan of attack, right? First, we need to start and find out how many units total this person has available, right? So conversion factor here is 100 units of insulin per milliliter. We have 3 ml. Pretty simple. 3 ml times 100 units per ml. That's pretty standard for insulin. Usually there's 100 units per ml in a pen. So for a 3 ml pen, that is 300 units. Okay, so we know how much is available, and we now need to find out how often this person is taking per day, and then by that we can find out how many days this person has available to them. So our sig, right? Dose is 35 units BID. So 35 units twice a day. That's 70 units per day. Okay. So we can do 300 units times uh, for every 1 day the patient is using. 35 times 2, 70 units equals, dandy calculator, 300 divided by 70. 4.3 days. Technically, you could say 5 or 4. Yeah, just because you're not going to use um, effectively. You want to use a partial amount of insulin. So 4 days is probably more realistic. Pretty simple. Just how you approach, right? That's the main goal with these videos. Can I erase? Yes. Okay. Second question for this chapter, it's number 5. Number 5 was a homework problem. Let's read that paragraph right there. A physician's hospital medication order calls for a patient to receive 1 unit of insulin injection subcutaneously for every 10 milligrams per deciliter of blood sugar over 175 milligrams of deciliter, with blood sugar levels and injections performed twice daily in the morning and evening. If the patient's blood sugar was 200 milligrams per deciliter in the morning and 320 milligrams per deciliter in the evening, how many total units of insulin injection were administered? So, what is this? What is this question asking in layman terms, right? So they're just saying that for in a hospital, if a person's uh, if a person's blood sugar is over 10 units over 175, they will administer, was it 1 unit? Yeah, 1 unit of insulin injection. So for every 10 units over 175, right? So they're giving us uh, two um, two concentrations of blood sugar, and they wanted us to find out how much insulin was administered both for each time and total together. So that's what we're trying to find out here. So how do we go about this, right? So patient's blood sugar was 200 milligrams per deciliter in the morning. So we need to find, that's over 175, obviously. We should find out how much over, and then from that, divide that by 10 milligrams per deciliter to find out how many units per that amount was administered. Writing it out will make more sense. Okay. So 200, let's do the morning's dose of insulin, okay? So 200 minus 175. Patient was over 25 milligrams per deciliter of blood sugar, okay? So, so based off of that, divided by uh, 10 milligrams per deciliter. Okay. We're trying to find out how many units would be administered per increase of 10 milligrams per deciliter. That would reach an increase of 25 milligrams per deciliter. 25 divided by 10, that's 2.5 units. So 2.5 units in the morning. Now we can go and look at the evening dose. Evening dose was 320. 320 minus 175 equals, try to do a little math here, 145? Take a look. 320 minus 175. Yep. 145 milligram per deciliter. Okay. Divide that as well, just like we did last one. And we'll get 14.5 units. Okay. Morning dose, evening dose. They want to know how many total units of insulin was administered. So just simple addition, morning and night. 2.5 plus 14.5 equals 17 units. So, we've seen questions, a lot of words in them, but take the time to extract it, right? And it doesn't seem as hard once you really see it, right? All right. Last question of the chapter. Number 9. Not a homework question. Um, these use units called TCID. It's used for in relevance to viruses, and it just shows the amount of the amount of a virus that is able to infect 50% of host cells. It's a form unit. Okay. So number 9, each 0.01 milliliters of a mumps vaccine contains 400 TCID 50 of the mumps virus. If the usual dose contains 20,000 TCID 50, how many milliliters of the vaccine should be administered? So they have this amount of volume per this many units. They're trying to find the relative amount of milliliters for this amount of units. Sounds like a proportion. So let's write it out. So fusion 0.1 ml 400 TCID equals X, what we're trying to find, right? 20,000 TCID 50. All we had to do is so isolate and find for X. 20,000 times 0.01 divided by 400. All right. X equals 0.5 ml. And I mean, you could, really want to look into it. 20,000 divided by 400 is is 50, and then 50 times 0.01 is 0.5. So that does make sense. All right. And that's it for chapter 9. We'll move on to the next video, chapter 15. Peace.